Nicolas Brousse, gave this talk actually at PuppetCamp Paris. And here he is down here with us today. So we don't usually have talks that span that distance between when they're given. Julian was supposed to be here today, and he can't make it, so Nico's going to be both of them for today. Hopefully talk back and forth to yourself.
Yep.
We're really looking forward to that.
Thanks.
You.
So I'll do my best to represent Julian because he did most of the work I'm going to present. So my name is Nicolas Brousse. As you can hear, I'm French, so it's why I was also in Paris for PuppetCamp. What I'm going to show you is how TubeMogul use Puppet to improve our operation, but also how to keep our velocity and stay nimble in your industry. That's why we have this title about like 10,000 Puppet deployment. I will explain in a minute what that means. And what we did and what is our workflow that help us to reach this number. So who are we? TubeMogul is an enterprise software company for digital branding. It sounds like a lot of fancy word, but basically we are part of this ad tech industry where you have like online videos that are traded through a real-time bidding exchange platform. What we do that differentiates us from some other companies that we really focus on the software aspect of the system. We are not like making ads or selling ads. We are not like an ad agency. We are really more like doing the trade and the software solution of the platform. If it still doesn't speak to you on what we are doing, basically, when you go on YouTube, before you watch your video, you will have some ads. What's happened is that in real time, Google is going to contact a bunch of partners and ask like, hey, I have this user going to watch this video. Do you want to show an ad on how much you are willing to pay? All this happened in a couple of milliseconds. That's what I'm talking about here. This happened on YouTube, but it's happened on all websites that do video ads. This is something that is getting bigger and bigger. And TubeMogul is also pushing this on a TV platform. So it's what we call programmatic TV. Most of the ad today in the TV industry is ordered through like fax and all the mechanisms like that. We are just bringing like programmatic in all this industry. So that's what we do. And last year, we served about like 27 billion ads in 2014. And what it did represent is about like, it's over 30 billion ad auction every day. So it's really like a stock exchange system, but for the industry. Every day we are receiving a bunch of bids and we choose to make an auction. We are receiving a bunch of auction and we are choosing to make a bid or not. So it's about like 30 billions per day that can be matched as a HTTP request, basically. So it's a lot of traffic. All the bids need to be processed in less than 50 milliseconds. That's on our infrastructure side, because we have a tough requirement of like responding, including network on trip, in less than 80 milliseconds for most network. Some of them will go to 100 millisecond tolerance. Some of them will go to 200 milliseconds. It does put a lot of constraint. We could have more flexibility for the one with 200 milliseconds, but at the end, the system is the same for everyone. So we have to get all our bids in less than 50 milliseconds if we want to make sure to have an opportunity to win this auction. We currently serve about like 5 petabytes of video traffic. All this goes through our CDN provider. We don't serve directly video. We are really just and most of the ads don't even go through CDN. They will be served through the client one ad serving platform. So we are really just here to make the exchange. And we have about 1.3 exabyte of data stored that we parse frequently to improve our machine learning algorithm and try to analyze and optimize the way we are doing our bid. So that should give you an idea of what we are doing and what are some of our constraints. The team I work for and I try to lead is the operation team. Our goal is really to guarantee like smooth day-to-day operation. We want these things to work, and I'm sure you know what that means with on-call and things like that. We are trying to have like a cost-effective infrastructure while still trying to support and bring like new technology in this infrastructure. The team is composed of site reliability engineers, system engineers, and DBAs. We are 15 as of today. And we manage over 2,500 servers. They are virtual and physical. I will give more detail on that. So our infrastructure is complex because we have a lot of exchange points. Because we have this latency requirement, we end up having like a lot of location to help us to deal with network latency. So we use heavily Amazon as of today. We are in the process of switching some of our latency dependent infrastructure to some in-house location using Equinix data center and OpenStack. We currently have 7 cloud locations on AWS and 2 physical locations. And we have a lot of technology. That's one of our challenge, and that's where Puppet become handy, because when you have to handle so many technology, so many different deployments, when you have to handle some legacy infrastructure already and try to make the things progress, it became a real challenge. We have a lot of Java. We have a lot of MySQL database in different configuration, cluster or node, master slave, and things like that. A lot of different NoSQL solutions. We start to have huge infrastructure based on Kafka, which brings some new interesting challenge. A lot of other things we try to deprecate, like Terracotta or some Hadoop HBase, where we try to use that only for machine learning using like EMR services or Hubot, things like that. That make it much easier to operate. But all the other ones are like things that we are actively supporting. So it's been 5 years we are using Puppet. We went through a lot of big challenges. I joined TubeMogul in 2008. We were like about 7 people. The engineering team is about like 100 people now. So it's growing. For the first couple of years, we didn't need anything. We were just using like bash script and like homemade template system and things like that. There was very little instances. We went from like 2 or 3 to like a couple of hundred. But in 2010, when we were reaching like 250 instances, it was becoming more difficult to guarantee states. So we start to look at tools to do our configuration management. And Puppet obviously came in the discussion. We start to look at that. In 2011, we started to deploy Puppet 0.25, which was interesting. We quickly upgraded to 2.7 because there was like so much more things we could do and much more stability and consistency we were getting out of that. By the end of 2011, we were managing like 400 servers with just 2 contributors. By 2 contributors, I mean 2 ops people on this infrastructure. In 2012, we went to 800 servers with like 4 contributors. 2013, 1,000 servers, 6 contributors. And last year, we had to manage about like 1,500 servers, fully managed by Puppet. And we started to introduce a continuous delivery workflow. And it's what I'm going to talk a lot in the next slide. We were 9 contributors, and at the end of last year, we started to switch to a new workflow and using Puppet 3.7, trying to catch up on all the versioning and all that and prepare for the future switch of Puppet 4 if it's happened on our side. This year, we have about like 2,000 servers managed by Puppet. So you can understand with the first slide where I talk about 2,500 servers we manage. There's about 500 of them that are part of auto-scaling group or MapReduce process where we just build and prepare AMI, and then we don't have like a Puppet agent. So we still build some the base of those servers with Puppet, but they are really cloud-based server and ephemeral servers. The 2000 I'm talking here, they are like pretty much always on, and they are fully managed by Puppet. And we are about 13 contributors today. So 2,000 nodes served with our Puppet master, one Puppet master. We have about 225 unique node definition, which means like in our node manifest, you will have like 225 variation. We use regex to manage to have group of servers. But at the end, it's still 225 variation we need to figure out and manage and support with about 112 Puppet module. That was the number from April. So our virtual and physical server configuration use a master node. We build AWS AMI using Packer, and still we prepare the CMI with a master mode process. So we have like a temporary certificate that will just be used to build the AMI and then get removed. Our local dev environment are based on Vagrant, and they are also using a master mode approach. Only our OpenStack deployment is currently using a masterless mode, because we are trying to build this cloud in a way where there is like very little dependency, and we can always like reproduce the physical deployment. All our VMs are still managed with Puppet Master. Code review. We use a lot code review. I will start to go into detail of what tools and how we are using what. But one big thing that we wanted to do is to be able to validate or change. With that many servers, that many variation, it's very easy to do a mistake. Human error happen, and especially if you are doing a lot, you will do mistake. And so what we wanted to introduce is a way to have a second pair of eyes on what we are doing. The reality is that when your change is too big, your code review is useless. The person doing the review will just have a quick look and be like, oh, that looks great. But it's not properly tested. It's not like necessarily understood. The impact is not necessarily understood. So we really wanted to go in something like closer to the real-time continuous delivery workflow, where the change were small and the mistake could be caught fairly quickly. But we still use Gerrit, because we found like a great value to do code review with Gerrit. It's really an industry standard, given like the large amount of people using it. We like the fine-grained permission rules, so it allows us to have like different review group, different permission across like the engineering team. We do use that for all our project at this time. We plugged it to LDAP, and it allows us to do a code review per commit. So it really tried to force smaller change and simplify the review process. We love the stream event. I will get in detail a bit later on how we integrate that with Jenkins. We use Git bleed just for some fancy UI stats and access to the repository. We integrated with Jenkins and Hiera, and we currently manage about 600 Git repository. So there is 112 that are our Puppet module, and the rest is a bunch of engineering project or some other code we have. What's happened in Gerrit is that for all our Puppet code, we have Jenkins doing the verification. And the basic thing it will check is that do you have a ticket number? This takes care of our change log and change control and compliance by ensuring that any changes that are being pushed in production are related to a task that has been identified. This really allows us to keep our engineering team and especially our operation team to move quickly without too much process. We just ensure that you have a ticket with whatever you are pushing in production, which normally means like the task has been identified and approved, and also make sure to do like some review of what has been pushed and what could be the cause of an issue or something like that. And the other thing it does, if Jenkins is going to do a bunch of basic check, like Puppet lint, YAML lint, all this kind of small check, ensuring that formatting is right. If you don't follow the standard we have defined, your code is not verified, and you have to submit a patch set. So that's really the basic things that we automate here. Ensuring that whatever you push is as a bare minimum, no syntax error, no things like that, and it's following all the standard we define. So with Jenkins, we have currently set up one job per module. So that means we have about 112 jobs. We have one job for the manifest on Hiera data. We are still using a YAML file for Hiera. We haven't moved that to any backend services. And we have one job for the Puppet file server, and one job to do the deployment. So when I say like we did 10,000 Puppet deployment last year, it's really 10,000 Puppet churns that went to production. So that means about 30 churns a day that are being pushed all over last year. That's where it's pretty great for us, and it's where we have found like a real comfortable way to work, because we have been able to continue moving fast and push any change, small or large, in a really nimble way. So that's what I'm talking about with 10,000 Puppet deployment. In the same time, our Jenkins infrastructure allows us to do about over 8,000 application deployment that is trying to follow also a continuous delivery approach. To manage all those jobs, we don't do it manually. We use a job DSL plugin from Jenkins. It allows us to code our jobs. So it's great because what we want to do with our infrastructure, we also do it to define the jobs that test our change. So with the job DSL plugin, we're able to define in a programmatic way how a job is defined and how we want what are the different steps, basically. So we also leverage like some other plugin, like the pipeline plugin from Cloudbase. We use node label plugin that allow us to define like slave for some deployment and things like that. There is a bunch of other plugins we are using to validate different state of the code. For Java code, we have like Sonar that is installed, things like that. And we can define everything with this DSL and make sure that we version that. It's also versioned in Git. And whenever we do a change, Jenkins picks this up from the repository and rebuild all the job automatically. So we can easily test. We create a branch in Git. We can test that on our dev Jenkins, make sure everything is fine. And when it's good, we can push that in our production Jenkins and get that redeployed and rebuild. The great thing is also that it gives us a DR strategy for Jenkins. If we lose everything, well, that's fine. We can rebuild it easily from the DSL. So that's a really cool plugin. What it allows us to do, too, is that we can easily integrate all our job notification with HipChat. It's one of the tools we are using to keep communication high. So whenever there is a change working or failing, it's currently pushing that in a special room in HipChat. We have similar things with Hubot, where it's listening to the Gerrit stream event. And it's really why we love the stream event from Gerrit. You can plug whatever you want to know what is going on in Git, and you can define like action based on that. And so we plugged Hubot to our Gerrit stream and start to get report in a specific room to know like what is being pushed, is there any code review happening, and things like that. Pretty cool too. All right. The continuous delivery workflow, I talked really high level, and I will try to go a little bit more in the detail on how all these things, all those tools work together. But the ideas, the initial vision we had like in early 2013, in late 2013 to get that in 2014, was really to think about our infrastructure as code. That's the trend right now. And we were trying to figure out how to make that a reality. So we wanted to follow a standard development lifecycle. We wanted to have like a development process and then push to production, be able to QA our code, be able to test and validate things, and be able to reproduce easily. We really wanted to have that to guarantee, to be able to repeat and guarantee the way we deploy a server. We wanted the continuous delivery aspect to allow us to continue to iterate quickly. As we are growing, we went public last July. So we are growing, but we have like more process coming. And the question was like, how do we keep the quick startup approach while still growing the team and still have to follow some of those compliance things. So we really look in detail on how we can smartly implement a continuous delivery workflow, and how we can automate our code review to improve our code quality. As the team grows, we all have like different style of coding, and sometimes some people will get more lazy than others. And we have legacy to manage, so how do we get the legacy to a better standard? That's what we wanted to do, so we introduced all this Jenkins process. And that was, the point was also to improve our reliability by having a better control on what's going to production and prevent like dumb mistake, and also try to start to implement better security practice. So the workflow. That's basically what I presented, but in a fancy diagram. It's not sure if you see properly, but basically we have our dev environment at the first step with Vagrant and Docker. It's where you work. Your day-to-day work, it's here. You are able to build your module or change things locally and test it locally. We have a full setup that allows you to do like a full Puppet deployment locally and validate that what you did is working. Once you are happy, you are going to commit your change. This is the first step of Gerrit, where you'll have to push either in a module or either in the repository that manage your Hiera data or all the node manifest. Once it has been a code review, so depending on the case, in dev, you will have like a code review automatically done by Jenkins. If you don't follow some standard, you will need to have like a manual code review. So someone else will have to review your change. Once it has been validated and reviewed by, verified by Jenkins, Jenkins obviously sends notification to HipChat, but it will also update the master. So it will just go on the master, do the Git update, update all the submodule, and work that way. Once it has been updated on the master, we have like a cron tab running depending on the server, every 30 minutes or every hour. And we have like a simple Puppet wrapper that makes sure to have the agent running, and will pick up the change. So that's basically the workflow. What it really means is that in a few minutes, you can have your change pushed to all your servers, or 2,500 servers. Sorry, 2,000 servers. Yep, that's it. All right, so the logic. We are trying to separate the Puppet code in different environments. We have a development environment and a production environment. So those environments have like dedicated node manifest, and they have also like different modules deployed based on submodule. The dev environment will use a dev branch of the module, while the production environment will use a prod branch of the module. There is some limitation. I will cover that later. We are in the process of moving away of this, but it's been working well for all past year and still working for all our infrastructure right now. All the data are in Hiera. We try to avoid like params.pp class. We store everything in module parameter. We store everything in Hiera, like module parameter, classes, keys, password, everything is there. I will cover a little bit more about the password. So what it looks like in the hierarchy, basically you can see like in the environment, you have the dev environment where you have like different manifests on all the modules that are like checkout of the dev I mean, it's a submodule, so it's a submodule that points to the dev branch. And in production, the module are just the one pointing to production. So it's really what your etc Puppet looks like right now. The Hiera configuration, you can see that it's a very simple one. We have different backend configured. The YAML one, I will give more detail in a second, but basically it allows us to encrypt password and things like that in Hiera, so we can get more open on who can access those data in Git. Because the goal for us is not to have just ops to access our Puppet code and our Hiera config, it's to also have like developers to start using it and contribute to the code. We are trying to open that, so because we know that we can't have more and more ops, so we want to give more and more responsibility to the developer on some of this change. So the YAML just configures the certificate for Puppet to decrypt everything, and we have a simple hierarchy that is currently based a lot on host name or zone. The zone is really like the geographic location. So the group will be like a cluster definition, things like that. So it's really specific to some Amazon approach we had, but we have been able to take the same approach with our on-premise setup and also with OpenStack environment. So YAML, that's the Hiera backend we are using to encrypt everything. I told briefly about it, but what it looks like in your YAML is just like your parameter end up being encrypted. It's really easy to edit. You just use YAML edit and you edit your YAML file. You will see in clear your password. You can edit it and you can close that. What it gives is that you can control who has access to what, and so you can start to have more password in your YAML file and start to have like developer contributing to your YAML configuration. If they want to change like a Java version from 1.7 to 1.8 on some dev environment, well, there is nothing that prevents you to give them access to this YAML file. They won't see what you think is really important, like all the credential. You still need to do like rotation of credential and things like that. But we also use black box. Same thing. We use that to generate to encrypt, like, for example, SSL certificate or SSH keys that we want to share and save somewhere. That's pretty cool tool that we use like even more than outside of Puppet. We use that to encrypt a lot of files that we need to share across our team, and we can choose who have access to it. That gives us a lot of flexibility without worrying too much about access. The workflow, that's a duplicate slide. Some of the bottleneck with this workflow. Currently, like, we are the only ones that can commit, and that's a real bottleneck. We really want to open that more and more to our engineering team. And this is due to some of the submodule and some of the legacy code that we have. So we are trying to move faster in migrating all that so we can start to give more access. The review on the validation is done only by the SRE. Currently, like, we prevent Jenkins to validate the commit because it doesn't have like a good, we haven't implemented like a good way of testing and validated that your change is not going to impact a server in a different zone or region or something like that. And we have like static Puppet environment. We have dev and prod. That's a pretty big limitation when you start to test and experiment new environment, or when we want to deploy like something new. We are really stuck in this dev and production environment. And it relies a lot on server host name. So we have all those non-manifest, and we say like, oh, if you're a bidder, your name like that. And it's great, but at one point it prevents you to do like efficient auto-scaling. It prevents you to do like a lot of other things to rely so much on host name. And we do want to keep Puppet because it does help us to move fast. So the idea is to remove all those bottlenecks. So workflow we started to introduce late last year, and we are still like working out moving to, is to leverage R10K. This allows us to get rid of the Git submodule, which is a bit of a pain to manage. There is sometimes some issue with Gerrit that use JGit and doesn't necessarily work well with Git submodule. And there is also this also removes the limitation of limited number of environments. We can have as many Puppet environments as we want, and this is really, really cool. If you want to test your one module or in a new infrastructure that need to be deployed for new services, you don't have to worry about like impacting something else. You just define the module you want to use, and you can get going. And you can like specify like a specific branch if you want to use like I don't know, like your MySQL module in Puppet is, you want to change it from the standard MySQL to MariaDB. You create a new branch, a future branch. You can test that with just like this one using this branch without impacting the production. So it gives like a lot more flexibility, and we are starting to use that everywhere. And that allows us to reproduce much more easily like environment. So the idea is that when we have the full platform switch to that, we'll start to introduce in Jenkins a possibility to just read a Puppet file that will define all this environment and test the module in full, and make sure to have like all the dependencies and things like that. So it's pretty cool. It does, a Puppet file looks like this. You can define like the main repository, the forge, and you define like all the module you want to use and get deployed in this environment. With some like specific setup you can have. And so if you want to test like your specific branch we have this time zone module, you can just define like a different branch name. So you don't have to depend like on dev, prod, you can use whatever you have in your Git repository. So it's pretty cool. And then you just run R10K on this and it's done. Other things we are adding, because we are growing, same thing with all those non-manifest. We really want to get rid of all the if, else, and on all this crap that start to pile up in your non-manifest things. So we are trying to push more and more to the role and profile and get like better practice on that. The role really defines the business logic, while the profile like is really going more into detail on how what kind of application and how you deploy it, still leveraging like Hiera for parameters and things like that. So that's how, well, I guess if you're not familiar with role and profile, it's what it looks like. It's not in the same file. It should be like in separate. It's actually used in a Puppet module. There is a Puppet module called role and a Puppet module called profile. And you will start to define everything in this module. The other things we want to get rid, so it's start to have like a nodeless approach. We try to leverage the fact to have the Puppet agent to know what it should deploy. We want to label our servers to say like, you are a bidder, you are like a web frontend, you are a database, instead of having to give a host name and say like this host name matches that. When you start to have like too many servers, it's just like a bit of a pain to do it like host name based. So we really want to just do it like per label. We are currently leveraging like Puppet Fact to do that. It allows us a really simple to have like a really simple site.pp. As you can see, we just like currently use what we call the EC2 tag TM role. We have this one also in our on-premise services and OpenStack deployment. So it's called EC2. It's a bit dirty, and we will probably change that. But it's actually a fact that we're able to define in all the environments we have, Amazon or not. And based on this role, based on this tag, it knows what it needs to deploy using the proper role. So here we leverage also the role and profile pattern. So all those tags are used like during provisioning, and we use the AWS Ruby SDK. We call like some factors that define this, us to find like what is a cluster, what is the Niger source that we are using for monitoring, different tag name, the Puppet environment that you want to have, so it gets provisioning with the right information for the puppet.conf, what is the role, things like that. The new hierarchy is following pretty much the same as before, but you don't have anymore like notion of hostname. We get rid of that. So it makes also the hierarchy much easier. So you know, like when you have like dependencies, what should be deployed and what will be the Hiera parameter used, it gets much easier to figure out instead of looking in 15 locations. With this new workflow, we allow people to contribute. So that's what we wanted, and it is happening. We allow everyone to review a Puppet change. Jenkins is still reviewing that too. Your review will be rejected if you don't have like a ticket or something like that. This allows us to have like system engineer and SRE to only be a bottleneck for like core Puppet change. Anything else can be like contributed by everyone else. And we are working on implementing like an auto-validation for whatever is in dev. If your code has at least 80% of unit tests and they are passing, we want to automatically like review it and merge it. That's something we are working on. It's almost there for some environment. We haven't put that in production yet, but it's something that we want to aim. Basically, we really want to make sure that our code review doesn't have any bottleneck on one or two people, and we can allow like automated tests and enforce like unit tests and good testing rules by allowing like a faster process. I'm not sure if I'm clear, but hopefully I am. So next improvement that we are looking for is start to look at Beaker and Docker. That's something we start to think more heavily. It's really to try to test how reproducible is our deployment and environment. We start to leverage server spec, and we want to push that even more, so we can have that plug in Jenkins and be part of this unit test I'm talking about, making sure that your module is following like the behavior of your module is really what is expected. We are looking at PuppetDB. We had some issue with that, but we still want to have like better reporting. Right now, we try to leverage our Logstash infrastructure where all the agents are reporting all the log to our Logstash infrastructure, and our PuppetDB dashboard right now is based on Logstash. And we are looking at possibly dedicating like Puppet Master in different regions, so we don't have like a single point of failure on our Puppet Master, because we still have just one. And that's it. Hopefully I was not going too fast. Yes.
Mike.
Thank you. You mentioned R10K was assisting you not using Git submodules. Could you go back to that slide, please?
Yes, I can. It's just leveraging the branch. Oops, this one?
The one before, I think. Yeah. Okay. So I'm still trying to understand how this is clearing you from the use of submodules. So when you're using a submodule, you're including another Git repository into another repository. That's how I've always used submodules.
Yep.
So how are you using R10K to overcome that?
So basically, the Puppet Master is configured to have, like, depending on the environment variable, we just automatically, or Jenkins workflow will just run your R10K, your Puppet file. So it will create this new environment on the master, and your environment is automatically configured and identified by the master. So basically, we just bypass all this static environment setup with Git submodule, because we just pull like what we need for this environment.
Okay, thank you. Mm-hmm.
I could show like more detail what it looked like if you want.
Oh, hold on. Oh, thanks.
What are your plans for the integration of Puppet with the Docker? I know I saw a slide out there, but
With Puppet with?
Docker.
With Docker? Well, so the idea is to simplify the way we want to test a provisioning. Some of the issue we got is you test something right now, you push it, and it looks great, it works. But like a few days later, you start to provision another server somewhere else, and it started to fail because there was like an hidden dependencies or whatever. So the idea for us is to try to integrate that with Jenkins to be able to test all our different set of variation of a server. So when we push change, we can like test quickly all the variation and make sure that there is no like hidden dependencies that may have break somewhere. So that's the idea, if it makes sense.
Yeah, when you say variation, what kind of variations?
Well, basically, like if your setup works in one zone, is it going to work when you have like? Let's try to take an example. You did a change for like our time zone module, and it seems to be working on the environment you tested, but does it still work in the other environment where this module is used? So basically, it's to try to identify where the module is used and try to test it in all those different environments to make sure there is not like conflicting setup. If you remove a parameter that you don't use in the module, but it has been used somewhere else, do you see that right away? Okay. So it's really just to try to push further the way we are going to test. We don't have like a fully defined workflow yet, but we are thinking heavily on that. And to clarify on the Docker approach, it's really just because it will go faster for the setup. It's nothing else.
Hi. Can you talk a little bit about the kind of testing you do and how much of that is automated and how much of it is manual?
So right now, we don't do enough testing. What Jenkins is doing right now for most of the tests is running Puppet lint, YAML lint, and there is another one that I'm missing. But basically, it checks like for syntax errors and formatting things. What we want to add is really this layer where we want to run server spec and validate like either in and out really what we expect. So the new workflow we are working on is able to do that, but we don't leverage enough the server spec. But it's where we are heading to.
Cool. Thanks.
So I have a question about your architecture. You said you just have one puppet master right now. And some of the things that people always said when they went to the masterless or non-master-based, agent-based, is it scales a little bit better, right, as far as the number of nodes that connect to a master at any given time. You also said that right now you just have one master running.
Yep.
And HADR, I've seen some slides on it, but can you talk about like some of the things you're planning on doing?
You mean to distribute better the master?
Yeah.
So what we were thinking of at one point was to leverage like slaves. If we want to distribute, it's not even like just for redundancy. One of the main factors is also like for performance. So if we can have like different master in different regions, we save on bandwidth, we save on speed, and things like that. So that's one of the things we are looking at. So we will just mirror, and when we push, we just make sure like each master gets the updated information. So we'll have like local Puppet master everywhere. That's one of the things we are looking at. Yeah. And certificate shouldn't be an issue because it can be like localized. Your agent is not going to try to report to a master like in Asia or something like that. Yeah.
Other questions? Anyone else?
Cool.
Perfect. Thank you so much, Nico.
Sure. Thank you.